Key features of an absolute value graph. After this lesson, you will be able to define key feature vocabulary terms and identify key features from an absolute value graph. So as we take a look at this first graph, we're going to go ahead and plug in all of these x values into the function y equals absolute value of x. So for example, y equals the absolute value of -3. What does the absolute value do? It removes the sign. So the absolute value of -3 is just 3. Go ahead and do your best to fill out the rest of the table. Check your work. So we end up with 2, 1, 0, 1, 2, and 3. We're now going to plot this on the graph. -3 is to the left 3, and then +3 is up 3. -2 to the left, +2 is up. Go ahead and graph the rest of the points from the table. So we end up with 1 here. Notice, what shape does it make? A V. If we connect our dots and add our arrow, you can see that an absolute value function creates a V where we have kind of a mirrored this half onto this half. So let's talk about those key features that you can see. First, we have the vertex. The vertex is the maximum, known as the highest, or minimum, known as the lowest, point on the graph. Try your best to look at these 4 graphs and determine if the vertex, which is the center point of the absolute value graph, is the highest, maximum, or lowest, minimum point on the graph. This one here, I can see that the vertex is below the rest of the graph. Below is the lowest, so it's a minimum. Same thing here. This vertex is below the rest of the graph. It's the lowest point, so it's a minimum. This one is above the rest of the graph. Above is the highest or maximum point. Same thing for this last one. We have a maximum. So that vertex, that center point on the graph, the point where the V is in the middle, we know that it can be the highest maximum or the lowest minimum point. The next key feature we're going to talk about is the axis of symmetry. It sounds pretty cool. It's a vertical line, so that's where it's going straight up and down, vertical, that divides the graph into 2 equal parts. So basically it's like if I took that V and I folded it in half. The line where I folded it would be my axis of symmetry. Symmetry just means it's the same on both sides. The equation is x equals a number. So that's why you can see x equals under every single one of these graphs for the axis of symmetry. Now that number is the x value of the vertex. So I know that if I can find my vertex, in this case is -1, -3, my x value is going to be my axis of symmetry. So at the vertical line, x equals -1, I'm going to be able to fold that graph in half. Try your best to find the axis of symmetry for the next 3 graphs. Check your work and be fantastic. So I know I have here x equals 0, since my vertex is at the point 0, 0. I know this one is going to be 2, because my vertex is at the point 2, -2. And last but not least, we also have x equals 0 because this is at the point 0, 6 for my vertex. Now notice the second and fourth graph have the same axis of symmetry. And that's okay because their vertexes can be different and still have the same axis of symmetry because it's just the x value of the vertex. The y-intercept. This is something we've talked about before. It's the point where the graph intercepts or crosses the y-axis. It can be the same point as the vertex. Do your best to identify the y-intercept of each of these 4 graphs. Check your work. You are the most amazing person who ever lived. So we know on a y-intercept, x is 0. So we're going to put 0 for all of these graphs on the x value. Then we're just going to identify where it crosses the y-axis at -2, 0, -4, and 6. And there's our y-intercepts where the graphs cross the y-axis for each of these graphs. Next, we're going to talk about the x-intercepts. X-intercepts are the point where the graph intercepts or crosses the x-axis. It can be 1 point. In this example, there's only 1 because it's the same as the vertex. 2 points, that's like first and the fourth graph where it crosses twice, or no points, which is what you see in graph number 3. Do your best to identify the X-intercepts. Check your work, you awesome person. So we know in an X-intercept, Y is 0. So I'm going to put 0 for all of my Y values. Then I just go ahead and identify the X values of where it crosses. This one crosses at the origin, this one crosses at -2 and 2. Now this one, notice how it never crosses the x-axis. So that means there is no x-intercept. And that's okay. Just because some graphs have a key feature doesn't mean this key feature is shown on all the graphs. The next one we're going to talk about is the domain. What do you remember domain stands for? Well, domain is the possible x values included in the graph when it's written in interval notation. So we see our x-axis goes side to side, as you can see with this orange line. So if we were to continue these graphs, I'm going to go ahead and add arrowheads to show you that they go on forever. So my question for you is, how far to the left do I go? I just keep going. And when you keep going, you eventually hit an infinity. Because it's to the left, it's negative infinity. Do we use a bracket or a parenthesis for infinity? We use a parenthesis because you can never reach infinity. How far to the right do I go? I go on forever. So I know that I'm eventually going to hit positive infinity. And again, it gets a parenthesis because you can never touch infinity. Can't touch this. Do your best to find the domain for the rest of these graphs. Check your work. You might be annoyed or happy to find out that the answer to all of these is negative infinity and positive infinity. The reason why is as long as an absolute value is a function, meaning it crosses the vertical line test, it will always allow any x value into the function. So that's why we have negative infinity to positive infinity, which is like saying all numbers. The last key feature we're going to talk about is range. What do you remember range is? Well, range is the possible y values included in the graph, written in interval notation. So for my range, as I can see, I have this red line on my y-axis because I'm looking at the graph from the bottom to the top. So this also has to do with our vertex. If our vertex is a minimum, then I know that the y value of my vertex, so my vertex is at -1, -3. It's a minimum. It's the lowest point. So it's actually going to start my range. Would I use a bracket or a parentheses for -3? I would use a bracket because this vertex point is included in the graph. Now, we know that these go on forever, which means we are forever going up. What value will we eventually reach? Positive infinity. Do I use a bracket or a parenthesis? Parenthesis. And there's my range for the first graph. Do your best to find the range of the second graph. So again, I want to identify my vertex. This is at the point 0, 0. So I know that 0 is going to start my range because this is a minimum value. So I know that I'm going to have a bracket because it's included, and it goes forever up, so I know that it's going to be positive infinity with the parenthesis. Try your best to find the range of the third graph. The third graph has a maximum point, or the highest point. So we still are going to use the vertex. We have the point 2, -1. We're looking at the y value, but it's not going to start our range. This is going forever down. Forever down eventually reaches negative infinity. With a parenthesis, what's the highest point we go to? -1 with a bracket. So again, when it's a minimum, your vertex starts your range. If it's a maximum, your vertex ends your range. Try your best for graph number 4. So again, we're going forever down. From the bottom, we're coming from negative infinity, and we reach the ceiling at +6 with a bracket. And there's your range. Now we're going to put it all together by looking at these examples. we're going to have to identify the key features of the given graph. So go ahead and remind yourself of your notes that tell you about all of these key features and fill in the important information. Our vertex is at the point, right in the middle, -2, -3. Hopefully your handwriting's better than mine. Is it a maximum or a minimum? The highest or lowest point? It is a minimum. It is the lowest point. My axis of symmetry, you must remember, is x equals a number. It's the x value that cuts it directly in half. And in this case, it is at -2, which is also the x value of my vertex. My y-intercept is where it crosses the y-axis. So we're at the point 0, -2. I'm going to cross the x-axis at 2 separate points. So first we're going to be at -8, 0, and second we're going to be at 4, 0. For my domain, I go forever to the left and forever to the right, so I know I'm going to have -infinity to +infinity, which is the answer most of the time. And then for my range, because it was a minimum, I know I'm going to start with my vertex value, which was -3. It gets a bracket because it's included. It goes forever going up, so we know we're going to have +infinity with a parenthesis. And there you have your key features from this graph. Try your best to identify the key features of example 2. Check your work. Be awesome. Our vertex is at the point 0, 6. It is the highest point, so it is a maximum value. Our axis of symmetry is x equals 0. Again, it's the line you'd fold it in half. It's the x value of our vertex. Our y-intercept is also 0, 6. The vertex and the y-intercept can be the same thing. We have 2 separate x-intercepts, so we are going to have the point -2, 0, and we're going to have the point 2, 0. Our domain, we go forever left, forever right, so we're at -infinity to infinity. Our range, since this is a maximum value, means we're going to start from the bottom, which goes all the way down to -infinity with a parenthesis, and the ceiling is at 6 with a bracket. All right, one more. You got this. Please do your best to identify the key features of this graph. Check your work. Be amazing. So we have our vertex is at the point 2, 3, and we know that that is going to be a minimum value because it's the lowest point. My axis of symmetry is x equals 2. That's the x value of my graph, or my vertex. My y-intercept is at the point 0, 7. It's where I cross the y-axis. And I put none for x-intercept because it does not ever cross the x-axis. My domain is still -infinity to +infinity because I can go forever to the left and forever to the right. My range, because this is a minimum, is going to start with the y value of my vertex, which is 3. 3 with a bracket because it's included. And it is going to have a ceiling of +infinity because we're going forever up, and we seal the deal with a parenthesis. Fantastic job. I lied. It's not the last one. Mwahaha! Do your best on example 4. I believe in you. You got this. So we take a look, and we have a vertex at 6, -4, which is a minimum value. Our axis of symmetry, we can fold it in half, is x equals 6. Our y-intercept is 0, 2. Our x-intercepts is 2, 0, and 10, 0. And our domain is -infinity to +infinity, while our range is -4 to +infinity. Go ahead, try your best on example 5. Look alive. You got this. This one was kind of fun. We're at the vertex of 0, 0, right at the origin, which is a minimum value, the lowest. Our axis of symmetry, where we can fold it, is right down the line at x equals 0. And we have a y-intercept at the origin 0, 0, an x-intercept at the origin 0, 0. The domain is -infinity to +infinity, and the range is 0 to +infinity. Great job getting through these notes. Please do your best on the practice for this lesson, and just remember, you are awesome.